The brain. Have you ever stopped and thought how amazing our brains are? Neuroscience is the study of the brain. Neuroanatomy is examining specific parts of the brain. Let's take a journey inside the mind and see what we find. Most of what you know, or think you know, is likely to be outdated. No wonder, the brain is the least studied topic in the field of science. The majority of the information we have has been gathered within the last 10 to 15 years. At the end of this module, you will be able to explain the difference between neuroscience and neuroanatomy, list the parts and functions of the brain, understand the parasympathetic response, and identify executive functioning skills. Our brains are responsible for survival, thinking, and feeling. Understanding how the brain develops, functions, and processes are important for both students and teachers. The information helps us identify why we make decisions, but not necessarily what the decision is. You're never too young to become a neuroscientist. Our brain is comprised of the brainstem, limbic system, amygdala, cortex, and prefrontal cortex. Over the next few slides, I will be sharing an explanation and examples of each section of the brain. Our brains develop from the bottom to the top and from the inside out. The brainstem is the part of our brain responsible for survival. Because of the brainstem, we are able to breathe, blink, and keep our hearts beating automatically. The brainstem is also the bridge between our body and our brains. Sensation arouses the brainstem and reacts accordingly to keep us alive. Up next, the limbic system. This part of the brain controls our behavioral and emotional responses. These behaviors, such as feeding, reproduction, and caring for our young, are just a few examples of how our limbic systems keep us and others alive. We've covered these responses in another module. Our limbic system is comprised of the thalamus, hippocampus, and amygdala. The thalamus makes sense of what we hear, taste, and see. The thalamus processes those experiences and determines which part of the brain the information should be sent. The hippocampus is in charge of our memories. This part of our brain also stores our long-term memories attached to a feeling. Our bodies have an automatic reaction when we experience a familiar smell, taste, feel, or sound. Think of a nursery rhyme from your childhood, or maybe the smell of chocolate chip cookies baking. Something connected to an important event or action. These feelings cause involuntary responses. The emotional response can brighten your day or bring you down. Yet, it's impossible to change that response without changing our thought patterns. We will discuss just how to do that in a separate module. Our memory of events and memories shape how we view similar objects and situations throughout our lives. The amygdala processes thoughts of a feeling. Did that thought make us happy, sad, mad? Sometimes our feelings and emotions create a block or don't necessarily match up with the logical part of our brain. As discussed above, the amygdala has a strong reaction to emotions and feelings. When the amygdala feels threatened, it immediately goes into survival mode. In this mode, we lose our ability to think clearly or logically. When triggered, the amygdala alerts the parasympathetic response by sending stress signals. Sometimes it's referred to as the amygdala becoming hijacked. The parasympathetic response controls our response to stress. Early humans were exposed to constant life-threatening events such as wild animal attacks and encounters with enemy tribes. To increase the chances of survival, the fight, flight, or freeze response began to evolve. It's an automatic response to physical danger that allows you to react quickly without thought. Our bodies are not designed to endure constant stress. Initially, it was a matter of life or death. Today, we experience significant stress on nearly a daily basis. Chronic stress can cause an array of health issues. The cortisol released blocks the immune system from doing its job effectively. This can lead to heart disease, cancer, depression, and a number of other health concerns. The Polyvagal Theory. This theory is made up of two root words, poly meaning many and vagal meaning nerve. The vagus nerve starts at the top of our bodies and ends at the base of our spine. This nerve has branches that reach out to all the different parts of our body. This nerve is the captain of the autonomic nervous system. The sole purpose of the autonomic nervous system is survival. It connects our brain, heart, and belly organs. The Polyvagal Theory focuses on social connection and communication. It also plays a significant role in understanding trauma in our own lives and the lives of others. This theory explains our stress response. Not too many years ago, it was believed the body was either experiencing stress or it wasn't. All or nothing. Even going so far to say as there is good stress and bad stress. Today, we understand stress comes in many forms and varying intensity. Recognizing stress causes and the severity helps us understand and attend to the trauma the body is experiencing. Ever heard of the term right brain, left brain? This phrase introduced most of us to the next part of our brain, the cortex. Our cortex is made of two sides, or hemisphere, the left hemisphere and the right hemisphere. This part of the brain is responsible for our short and long-term memories. Back to the right and left hemisphere. We know the left brain is in charge of reason and logic, but did you know the left hemisphere is also responsible for the right side of our body? Yes, the opposite side. The right side of our brain is responsible for music, art, and the left side of our body. You may have heard the term crossing the midline. The body's midline is an imaginary line down the center of the body that divides the body into the left side and the right side. When you cross the midline, you are reaching across the body from one side to the other. Crossing the midline makes it possible for us to complete actions on the other side of our body. Think about a child sitting with his legs crossed, or drawing a straight horizontal line across the paper, or even completing a puzzle. The development of this skill helps us write, play sports, and do something as simple as put on our shoes. Oh, and identifying as being right-brained or left-brained, that's a myth. We have come to the last part of the brain, the prefrontal cortex. Remember, our brains develop from bottom to top. This section of our brain is the last to fully mature. Have you ever wondered why adolescents seem to make questionable decisions and at times put themselves in risky situations? Well, the prefrontal cortex is responsible for reasoning, logic, and responsible decision making. Does that answer the question to adolescent behavior? It is the prefrontal cortex that is in charge of our more complex behaviors. There is a theory among the scientific community that the prefrontal cortex is not fully developed until possibly our early 30s. Continuing with higher level thinking skills, we now come to executive functioning. Executive functioning is a critical component in our development. Because of this, it is the star of the show in a later module. For now, I will share a brief description and list these skills. Executive functioning skills are those higher level thinking skills that allow us to connect what we've learned and put it into practice, otherwise known as generalizing. Our brains are like a superhighway, a complex system. We have to manage not only what we see in front of us, but everything going on around us. While driving, we must be aware of other cars, the timing of lights, merging, and trying to anticipate what's coming next. Like a person behind the wheel, children must manage a lot of information and stimuli in their environment. Executive functioning is comprised of 3 skills: working memory, cognitive flexibility, also known as flexible thinking, and inhibitory control, or impulse control. These skills include paying attention, organizing, planning, prioritizing, and staying focused to complete a task. They also help us regulate our emotions and monitor our feelings. Let's wrap up. What have we learned? Our brain is responsible for our survival, our thoughts, and our emotions. The brain develops from bottom to top, and the lower parts of the brain are responsible for our most rudimentary actions. Our cortex is responsible for our memories. It's divided into the right and left hemisphere, each responsible for their own functions, and a prefrontal cortex, or the top of our brain. This is the last to develop and provides some insight into why children do what they do. Accompanied with this webinar are resources and activities for both you and your students. Check out the research articles, kid and adult-friendly neuroanatomy videos, and other materials. Be sure to teach your students to be neuroscientists and watch them understand their learning and development. Join me for each module and become an amateur neuroscientist yourself. See you next time.